it is trapped as methyl tetrahydrofolate. This trap is only relieved by B12 because B12 removes trap which is relieved by B12, and B12 becomes methyl tetrahydrofolate and forms methyl B12, methylated B12. And this trap is removed and tetrahydrolate is free to carry this thing. So there are three important points. One is folic acid is not there in the diet, or it is not absorbed from lower intestine, small intestine, for ileum, etc. Or dihydrofolate reductase is absent or is damaged or destroyed, or its activity is reduced, B. And C, if there is a deficiency of B12, again there will be deficiency of folic acid. Why? Because the folate, the moment it gets activated, it is trapped by methyl tetrahydrofolate. So, because if B12 is normal, it removes this methyl groups and forms methycobalamin or methy-B12, methylated B12, and tetrahydrofolate is free to carry on one carbon metabolism and DNA formation, as I told you previously. So, then a bit of clinical things over here. This, in addition to what I've already told, that you see that DNA formation, it is made of use of, for example, there is a drug called as Septron. Septron is an antibiotic. Septron is formed of two things. One is sulfanilamide and trimethoprim. So these are two things that combine together to form Septron. Now sulfanilamide is a competitive inhibitor of PABA. And you know, PABA is a component of folic acid. I told you, pyridine plus PABA plus glutamic acid. So if you give Septron, the sulfanilamide will resemble PABA, and so it competitively inhibits the production of folic acid, right? Trimethoprim acts and reduces and destroys dihydrofolate reductase. So in both cases, this folate is not formed. Sulfanilamide reduces the formation of folic acid, and trimethoprim will reduce the formation of active tetrahydrofolate by inhibiting the enzyme dihydrofolate reductase. So in both cases, folic acid will be deficient, DNA will not be formed. Now, Septron is an antibiotic. You can ask me, well, you take it for an antibiotic whenever there is infection. It's a widely prescribed drug. So, would it not affect the humans? The answer is that trimethoprim acts only on bacterial dihydrofolate reductase. Trimethoprim does not act on human enzyme. It acts only on bacterial. And the second thing is that it is only the microorganism that can synthesize folic acid. Humans must take it in diet. So no problem with humans. If trimethoprim is taken, it acts only on bacterial enzyme, and so the bacterial production is inhibited. Well, in humans, you have got another drug called as methotrexate that is given, that affects dihydrofolate reductase enzyme in humans, folic acid action, and methotrexate also inhibits DNA, but that is in humans. So all the cells that are rapidly dividing human cells, they are present in here, your blood cells and GIT and skin cells, but the most important are the hair cells and the RBCs, blood cells. So whenever there is folic acid deficiency, it's going to affect these two tissues. And the third is rapidly dividing cells, that is cancer cells. So methotrexate is an anti-cancer drug as well because it inhibits the formation of DNA. So just to cap it again, folic acid is very essential. It's a water-soluble vitamin, and especially so in females because it is very important in the development of fetus, because fetus is growing, rapidly dividing, and so the DNA is very important. And the folic acid helps in the formation of DNA because it helps the formation of both purines and pyrimidines. And the dose is 400 microgram per day. It must be taken in diet, and especially so in females, because if not taken in diet, in addition to having megaloblastic anemia, they will have serious fetal defects that I told. Anencephaly, absence of brain, and spina bifida. There is again developmental abnormality of the spinal cord. So thank you. We'll see it again. क्या हो गया इसको 40 मिनट्स हो गए। मैं वैसे पढ़ाता हूँ क्लास में, ये यदि आपको पसंद आता है इससे, ये देखें एंजाइम्स, क्योंकि बहुत मुश्किल है भाई।
ये पॉज किसने किया?
जी